Dear students, welcome to this lesson on language of chemistry. Today we are going to learn about writing formulae of compounds. At the end of this lesson, you will be able to write the formulae of compounds. In grade 8, you have learned that an element is represented by a symbol which usually consists of one or two letters. For example, the symbol of hydrogen is H and that of argon is Ar. Calcium has symbol Ca and iron has symbol Fe. You also learned that an element has a combining power which is called its valency. You will recall that the valency of hydrogen is 1, that of argon is 0. Calcium has valency 2, whereas iron exhibits 2 valencies which are 2 or 3. Please refer to your MIE textbook on page 394 for a recall on symbols and valencies of some elements. Now let's recall what you learned about compound. A compound consists of 2 or more elements chemically combined together. According to the language of chemistry, a compound is represented by a shorthand form called a formula. Therefore, each compound has a specific formula. Let's see how we work out the formula of sodium oxide. First, you need to identify the elements present in the compound. The elements present in sodium oxide are sodium and oxygen. Then you write down the symbol for each element. The symbol for sodium atom is Na and the symbol for oxygen atom is O. In the next step, you write down the valency of each element. The valency of sodium is 1 and the valency of oxygen is 2. Then you swap the valencies. By doing so, sodium obtains the value 2, which is the valency of oxygen, and oxygen obtains the value 1, which is the valency of sodium. The ratio of sodium atoms to oxygen atoms in sodium oxide is therefore 2:1. Then you determine the simplest ratio. Here 2:1 is already the simplest ratio. Thus, the formula of sodium oxide is Na2O1. Remember, if there is a subscript 1 in a formula, you should ignore it. Thus, the formula of sodium oxide is Na2O. You will recall from grade 8 that the subscript next to the symbol in a formula represents the number of atoms of that particular element. For example, the formula of sodium oxide is Na2O. The subscript 2 shows there are 2 atoms of sodium. For oxygen, there is no subscript. Remember, when there is a subscript 1 in a formula, you do not show it. Thus, no subscript means 1 atom of oxygen. As you may have noticed in the previous example, the term oxide refers to oxygen which has combined with another element. The table shows the term used to represent other nonmetals in compounds. For example, bromide represents bromine which has combined. Fluoride represents fluorine, and sulfide represents sulfur in a combined form. These terms are the second part of the name of a compound. For example, sodium bromide, calcium fluoride, and iron sulfide. Another example that we will consider is aluminum chloride. The elements present in aluminum chloride are aluminum and chlorine. The symbol for aluminum atom is Al, and the symbol for chlorine atom is Cl. The valency of aluminum is 3 and the valency of chlorine is 1. On swapping the valencies, aluminum obtains the value 1 and chlorine obtains the value 3. The simplest ratio for the valencies is 1:3. The formula for aluminum chloride is Al1Cl3. Ignoring the subscript 1 in the formula, we obtain AlCl3. As you have learned in grade 8, some elements exhibit more than one valency. For example, copper has valency 1 or 2, and iron has valency 2 or 3. The table gives you examples of some metals and nonmetals which exhibit more than one valencies. Now we will learn how to write the formula of compounds with elements having more than one valency. Let us consider the compound lead-4-oxide. The elements present are lead and oxygen, having symbol Pb and O respectively. Remember, lead exhibits 2 valencies which are 2 or 4. The Roman number between brackets indicates the valency of lead in this particular compound. This Roman number 4 shows that the valency of lead is 4 in lead 4 oxide. The valency of oxygen is 2. On swapping the valencies, lead obtains the value 2, oxygen obtains the value 4. Now, the simplest ratio becomes 1:2. The formula of lead 4 oxide is therefore Pb1O2. Ignoring the 1 in the formula, we obtain PbO2. Now, let's have a look at the formula of phosphorus 5-chloride. The elements present are phosphorus and chlorine. Phosphorus has symbol P. The chlorine atom has symbol Cl. Now you will recall that phosphorus exhibits two valencies, which are 3 and 5. In phosphorus 5-chloride, the valency of phosphorus is 5. The valency of chlorine is 1. On swapping the valencies, we get a ratio of 1:5. Thus, the formula of phosphorus 5-chloride is P1Cl5. Ignoring the subscript 1, we obtain PCl5 as the formula of phosphorus 5-chloride. Let's see how we work out the formulae of compounds with radicals. So, what is a radical? A radical is a group of atoms chemically combined together, and it behaves as a single unit. You will recall a radical is represented by a formula and it has a valency. For example, the radical hydroxide has formula OH and valency 1. Ammonium has formula NH4 and valency 1. You can see other examples of radicals in the table. Now let's have a look at the formula of copper 2 nitrate. Copper 2 nitrate consists of the element copper and the radical nitrate. The method for working formulae of compounds having radicals is same as explained previously. Copper has symbol Cu. Recall, copper has two valencies, which are 1 and 2. In copper 2 nitrate, the valency of copper is 2. Nitrate has formula NO3 and valency 1. On swapping valencies, the ratio of copper atoms to nitrate radicals is 1:2. Thus, the formula of copper 2 nitrate is written as Cu open bracket NO3 close bracket 2, which is read as CuNO3 twice. As you can see, in the formula of copper 2 nitrate, the nitrate radical is placed between brackets. The subscript 2 shows that there are 2 nitrate radicals in the formula. This subscript is placed outside the brackets. Note, in a formula, if there is more than one radical unit, then the radical is placed between brackets and the subscript is placed outside the brackets. Now, let's count the number of atoms of each element in this formula. There is no subscript for copper, hence there is 1 copper atom. In nitrate NO3, there is 1 nitrogen atom and there are 3 oxygen atoms. Since there are 2 nitrate radicals in the formula, the total number of nitrogen atoms is 1 times 2, which gives you 2 nitrogen atoms. Likewise, the total number of oxygen atoms is 3 times 2, which gives you 6 oxygen atoms. Another example is ammonium carbonate. Ammonium carbonate consists of 2 radicals, the ammonium radical and the carbonate radical. Ammonium has formula NH4 and carbonate has formula CO3. The valency of the ammonium radical is 1. The valency of the carbonate radical is 2. On swapping valencies, the ratio of ammonium radical to carbonate radical is 2:1. The formula for ammonium carbonate is therefore NH4 twice CO3 into brackets 1. Note, if there is 1 radical unit in a formula, then you ignore the 1 and you don't place the radical between brackets. Thus, the formula for ammonium carbonate is NH4 twice CO3. Let's summarize the steps to work out the formula of a compound. First, you identify the constituent elements or radicals of the compound. Then you write down the symbol of the elements or the formula of the radicals present. In the next step, you write down the valency of the elements or the radicals. Then you swap the valencies, and in the next step, you determine the simplest ratio of the valencies if necessary. In the next step, you write down the formula of the compound and you ignore any subscript 1 in the formula. You can practice writing formulae of compounds from your MIE Grade 9 Science textbook on page 398, page 401, and page 422. This lesson was presented by Ms. Dukia, Chemistry Educator. Thank you for your attention.